In this video, we'll be talking about how to find trigonometric function values using a calculator. We're going to be using our calculator to find values throughout this course, and our ability to use it properly is critical. We want to find a decimal approximation for each value. We'll round to the nearest 10,000th. Please note that your calculator must be in degree mode. Now, different calculators vary where that degree versus radian mode is. I've included several links to other videos in the description of this video to give you additional details on converting between degree and radian mode, as well as entering degree, minute, second notation into your calculator. So if you don't know how to do those things, you may want to pause this video, go check out the links that I have in my description. I have videos for several different calculators that you can check out. All right, well, we want to start by finding cosine of 57 degrees. So once we've made sure that our calculator is in degree mode, we're going to select the cosine button on our calculator, which just looks like COS, and then most calculators automatically open a parenthesis, and then we put our 57 in. You do not need to put the degree symbol in because we are in degree mode, and then we just hit enter on our calculator. Remember that the range for cosine is in between -1 and 1, so I'm anticipating a number in that range. Rounding to the nearest 10,000th, we get 0.5446. Next, we want to find tangent of -80 degrees 6 minutes. So this is an example where we need to know how to use the degree, minute, and second functions of our calculator. So as I said before, if you don't know how to do that, please pause this video, check out the links I have in the description, and get a little bit more detail on your calculator specifically. If you have trouble beyond that, please feel free to contact me and we can talk one-on-one about your calculator. So tangent of -80 degrees 6 minutes. Again, we're going to just type it in right as it is. But the degree, minute, second notation typically takes a few more clicks on the calculator. Rounding to the nearest 10,000th, we'll get -5.7297. The range for tangent is all real numbers. So we could have any type of number as our answer for tangent. Next, we want to find cosecant of 250 degrees. Now, you'll notice that there is not a cosecant button on your calculator. There's only ever a sine, cosine, and tangent button. So we're going to have to use our knowledge of cosecant and those other trig functions to be able to type this into our calculator. Recall that cosecant of theta is equal to 1 over sine of theta, because those are reciprocals of each other, reciprocal functions. So if I wanted to find cosecant of 250 degrees, I'd actually type into my calculator that I'm looking for 1 over sine of 250 degrees. And then this is what we'll put in our calculator. Remember that the range for cosecant is anything except between -1 and +1. I always like to have an idea of what my answer is going to be before I get it. That helps me throw out unreasonable answers. We end up with -1.0642. So in those first three examples, I gave you an angle measure and you found the value of a specific trig function. Well, now I'm going to tell you that a trig function has a specific value and we want to find the angle. We want to find a theta in the interval 0 to 90 degrees, so that's quadrant 1, that satisfies each statement and will round to the nearest 10,000th. Please note that your calculator is only going to give you answers in the first quadrant. And anytime you are looking to find an angle given the value of a trig function, you're going to be using the inverse trig function keys on your calculator. And they look like this. All right, we know from college algebra that notation almost looks like an exponent of -1, but it's not. Indicates inverse for us in the context of functions. So if you take a look at your calculator, you'll see that the second to your sine, cosine, and tangent buttons are sine inverse, cosine inverse, and tangent inverse. And that's the buttons that we're going to want to choose here. If sine of theta equals that decimal, then theta is going to be equal to sine inverse of this decimal. Sorry, it's just too long to say over and over again. All right, so we're just popping that into our calculator and it's going to spit us out an answer somewhere between 0 and 90 degrees. We're again rounding to the nearest 10,000th. We get theta to be equal to 57.9972, and our unit is degrees, because our calculator is still in degree mode, so the angle it's spitting out is a degree measure. In our next example, we've been given a tangent value, and we want to find the angle. So our angle theta is going to be tan inverse of our value. Plugging that into our calculator and rounding to the nearest 10,000th, we get theta equals 81.1681 degrees. And then let's look at one more. This time we've been given the value of a secant function at some angle theta, and we're looking to find the angle theta. Again, if we look at our calculator, there's no secant inverse button on the calculator. There's not even a secant button on the calculator. So we're going to have to think about what this means in relationship to sine, cosine, or tangent so we can actually use our calculator. We know that secant of theta is equal to 1 over cosine of theta. So substituting this in here for secant, we're going to get 1 over cosine of theta is equal to 1.1606249. We're trying to solve for theta, and just, algebraically, any time the variable you're solving for is located in the denominator, your number one priority is to get it out of the denominator. So we're going to multiply both sides by cosine of theta. Which brings us to 1 equals 1.1606249 cosine of theta. We're going to isolate the cosine of theta by dividing by this coefficient here. going to bring us to 1 over 1.1606249 equal to cosine of theta. And now that cosine is isolated, we can use cosine inverse to solve for theta. So theta is going to be cosine inverse of 1 over 1.1606249. And into our calculator, that goes. We get theta to be equal to 30.5027 degrees. A common mistake that I see with finding the angle, right, needing to use the inverse function for secant, cosecant, and cotangent is that people just want to say that theta is going to be equal to 1 over cosine inverse of the value. And a lot of times you're going to get an error with this. So sometimes your calculator catches your mistake that this is wrong, but not always. So just be careful with that we need to step it out kind of this way. And you don't necessarily have to show me all those steps, but we definitely need to be going through those thoughts as we're finding our theta value. If you're having any issues using your calculator, it's critical that you reach out to me early so that we can address those issues right away.